Evening, sir.
Good evening. Good evening. So, how are we today? Very good. Okay. So, beta, last class we covered up the topic or concept of stars suitable for observation. We saw that there are different categories with which we solve the questions. Stars within a certain hour angle, stars crossing the meridian, different types of questions, total five types. So, today we will be proceeding ahead and going into the rational horizon based questions. So these are some tricky and complicated questions which are based on the rational horizon. We had seen few questions on circumpolar bodies, and we had also seen the twilight concept where we use this rational horizon diagram. So today we will see few more questions on the same lines but little tricky and complicated. So this will clarify the topic of how to attempt these rational horizon questions. So this is the first thing which we will start with. And as we finish this, then we will move on to maybe the concept of time, and then later on, the chart projections, construction of the chart, these topics. Okay, so ready beta? चले start करें.
Yes, sir.
Okay beta, great. Let's go. Now, in some of these questions, beta, these rational horizon questions, some time related definitions may also be used. So I will tell you in detail about all these time related definition, but for now, one definition I will clarify. So that will be used in the question. Other definitions I'll tell you when we cover up the time topic. So let's do it, beta. Let's go into rational horizon type questions. Let me put up the presentation. In this presentation, we are going to learn about the numerical which are based on rational horizon diagram. Now, before we go into the actual questions, some of the questions have the concept of local sidereal time. So let me first explain to you what is the meaning of local sidereal time, also known as LST. LST or local sidereal time is the westerly hour angle of the Aries measured from observer's meridian. Let me show you with the help of a diagram. Let's make the diagram of the Earth looking from top of the North Pole. So if you look at the Earth from top of the North Pole would appear to be exactly in the center. This will be the North Pole, and the circumference which you see will be the equator. So we are looking at the Earth from top of the North Pole. Let's show the Greenwich meridian in this diagram. So by convention in these diagrams, we always show the Greenwich meridian pointing downwards. Now exactly opposite to it is the 180-degree meridian. Now let's assume our observer in this diagram. Let's assume the observer is at this particular location. We can now show the observer's meridian also. So this is the observer's meridian. Exactly opposite to this will be the inferior meridian of the observer. This is the inferior meridian of observer. Now let's assume that Aries was at this particular location. Now we can show the local sidereal time LST in this particular diagram. When you look from top of the North Pole, in this way, then the westerly direction is the clockwise direction. The clockwise direction in this diagram represents the westerly direction. You can see this arrow showing the westerly direction to us. So now we know LST is the westerly hour angle of the Aries measured from the observer's meridian. So we need to start or take our reference from the observer's meridian. From the observer's meridian, we need to go in the westerly direction. You see, westerly direction, and we need to go up to the Aries. So from the observer meridian, measuring the angle in the westerly direction up to the celestial meridian of Aries. This is what we call as LST, local sidereal time. Now this can be represented in angular units as well as in the units of time. In angular unit, it is represented in degrees. And if we want to convert it into the units of time, 360 degrees is equal to 24 hours. So this gives us a factor of 15. So when you measure this angle in degrees, you divide it by 15 and you will get the LST in the units of time also, hour, minutes and seconds. So this is the definition of local sidereal time. Westerly hour angle of Aries measured from the observer's meridian. Let's now go into our first question based on the rational horizon diagram. The question says, during morning twilight, an unknown star bore south with a altitude of 40 degree 20 minutes. During evening twilight at LST, local sidereal time, 3 hours 34 minutes and 24 seconds, the same star bore north with a altitude of 13 degrees 08 minutes. Identify the star. Now, before we start solving this question, I would like to explain to you the basic concept or the basic procedure which we follow in all these celestial navigation based questions. Now, the basic thing to be done is, number one, draw the rational horizon diagram. Whenever you get such a question based on principles of navigation, you draw the rational horizon diagram. And in that rational horizon diagram, you try to fit in all the required information which is given to us. So whatever information is given, a particular celestial body, its bearing, its altitude, or any other information, we try to put in that particular diagram. Now, as we put all this information in the rational horizon diagram, the diagram itself tells us or leads us to the solution of the question. In most of the cases, the question can be solved using spherical trigonometry. You will have a PZX triangle formed, and you can use the spherical trigonometry cosine formula or Napier rule. One of them will be applicable in that triangle, and by applying these formula, you will be able to solve the question easily. So this is the basic concept which we use. Make the rational horizon diagram, put all the information what is given to us in the question, and we will get a lead from the diagram itself how the question needs to be solved. Either it will be a very simple calculation, just adding or subtracting some values, or it will be a solution of the PZX triangle using the cosine formula or the Napier rule. Now let's try to check this concept, whether the concept works or not in this particular question. Let's fit these things one by one. we will first make the rational horizon diagram. So you make a circle and you show these 4 points representing the directions: north, east, south, and west. NESW, these 4 points are shown. Now at the center of this circle, we have the zenith. So we can join N and S, we can join W and E. The point of intersection gives us the center of the circle, which is the zenith. So the center of this diagram represents the zenith of the observer. The circumference represents the rational horizon of the observer. Now let's try to put all the given information in this particular diagram. Now they have told us that during morning twilight the star was bearing south. Now south bearing in this diagram is represented by this line ZS. ZS represents south bearing. The point S is on the rational horizon with altitude 0. The point Z is the zenith of the observer with altitude 90. So our star was bearing south. That means it has to be somewhere on this line ZS. So star bore south with a altitude of 40 degree 20 minutes. So our star, which is on line ZS, has a altitude of 40 degree 20 minutes. Now we know the radius of this diagram is 90 degrees because its center is zenith, the circumference is rational horizon. Every point on the rational horizon is 90 degrees away from the zenith. So the radius is 90 degrees and the altitude of the star is 40 degree 20 minutes. So that means it is 40 degree 20 minutes above the horizon. Now on this line ZS, S point represents the horizon. If you go 40 degree 20 minutes away from it, this is the location. 40 degree 20 minutes away from the horizon, this is the location where the star is. So we have shown the star's position at the time of morning twilight, and let's mark that position as X. Further, the question says during evening twilight at LST so and so, the same star bore north. So north bearing represented by Zn. The star had a altitude of 13 degrees 08 minutes. So it was 30 degrees 08 minutes from the horizon. Now N point represents the horizon here. So if we go 13 degrees 08 minutes above the horizon, this is where the star is at the time of evening twilight. Any doubts up to here, beta?
Excuse me, sir.
Go ahead.
This, sir, 40 degree 20 minutes in South Pole, that is measuring from S. Is it right? No, sir. Means in S altitude will be 0 and increasing, and up to Z it will be 90.
Yes, that is right.
Okay, sir. Okay.
That's right.
Yes,
Every
sir.
point on the horizon, whether it is north, east, south, or west, they are all at 0 degree altitude. As you come towards the center, which is the zenith, the altitude increases.
So at point of Z it will be 0. Okay. Okay, sir.
At
Thank you.
point Z, it will be 90, beta, 90
Yeah,
altitude.
90, sir. 90, correct. At Z it will
90.
be 90 and S it will be 0. Okay.
Yes, that's right. Now we have the location of the star at the time of evening twilight as well as at the time of morning twilight. It is the same star. Now the same star can be at these two locations, that is X location in morning twilight and X dash location in evening twilight, only in one way. Its declination circle has to pass from both these locations. The star always remains on its declination circle. And there is only one way a circle can be drawn passing from these two positions. How can we draw a circle? the circle can be drawn in this particular way only. So this circle, which is passing from x and x dash, represents the declination circle of the star. Now we are aware that at the center of all declination circles is the pole. So let's mark off the center of this particular circle. The center will be north of Z, because you see Sx distance is 4020, which is much greater as compared to Nx dash, which is only 13.08. So the circle is offset to the north. The center will be north of the zenith. And the center of the circle has to be the pole. We are aware that all the declination circles are centered at the pole. Any doubts, beta?
Selection of poles, sir. Can you explain this? Why we are taking this North Pole? Maybe it will be whether come to South also, or how can will be confirmed, sir? It will be going to North only.
Okay, beta, okay. मान लेते हैं that this pole is the south pole. Okay?
Okay, sir.
Okay, हमने मान लिया कि ये साउथ पोल है. अब बेटा मुझे ये बताओ कि जो Z है, Z point, is it south of the pole or is it north of the pole?
Z is south of the pole, sir.
Okay, that means the observer is south of the south pole, right?
Yes, sir.
Now think about it. Can you go south of the south pole, beta?
No,
Think
sir.
about it.
No.
Wherever you go, you will be north of the south pole, right?
Yes, sir. Yes, sir.
The entire earth, all the positions on the earth's surface are north of the south pole,
Yes, sir.
right? So
Yes,
this
sir.
immediately clarifies this cannot be the south pole,
South.
this has to
Yeah.
be the north pole.
Okay, sir. Yeah.
Clear हो गया बेटा?
Yes, sir. Yes, sir. Thank you.
See how easy it is, huh? Okay,
Yes, sir.
good. Now the star will be moving in this particular direction marked by these green arrows. This is how the star will be moving. We can also show the equinoctial in this diagram. Equinoctial is 90° away from the pole. So you go 90° away from the pole, and this point is the Q point from where the equinoctial is passing, and equinoctial always passes from the west and east points. So this blue color line which you see in the diagram now represents the equinoctial WQE. Now the LHA Aries is obtained from the value of local sidereal time. As I told you, local sidereal time is the westerly hour angle of Aries measured from the observer's meridian. And this is in the units of time, 3 hours, 34 minutes and 24 seconds. As I told you, we can easily convert it into angular units by multiplying by 15. So we multiply this LST 334.24 by 15 and we get a value of 53 degrees 36 minutes. So this 53 degrees 36 minutes is the westerly hour angle of Aries measured from the observer's meridian. And this is the definition of LHA Aries. In fact, if LST is given to you, if you convert it into angular units, it gives you the LHA of Aries. LHA of Aries is the angle at the pole contained between the observer's meridian and the celestial meridian of Aries measured westwards. And this is exactly what LST is.
Sir, that day when we did star identification, we discussed that we divided by 15 degree 02.5 minutes, correct? Now we are doing by 15. What is the difference, sir?
Okay, beta. Be very, very careful in this, beta. Whenever you are finding out the motion of a celestial body, a star is moving in the sky, and you want to find out in 1 hour how much it will move. The motion will always be 15 degrees, 2.5 minutes per hour. Okay.
Okay, sir.
But whenever you are converting angle into time or time into angle, irrespective of whichever body it is, whether it is Aries or it is star or it is sun or moon, whenever you are converting angle to time or time to angle, it is always the factor of 15, because 360 degrees are covered in 24 hours by all the bodies.
Okay, sir.
Okay. So
Okay, sir.
360 degrees completing the full circle, making it 24 hours, gives us that factor of 15 for conversion. So whenever converting time to angle or angle to time, it will always be 15. When you are looking for the motion of the bodies, then it will be different.
Okay, sir. Understood.
Okay, beta. Great. So multiplying the LST by 15, we get the value of LHA Aries, which is 53 degree 36 minutes. Now let's show this value in our diagram here. The observer's meridian is represented by PZQS. This particular line represents the observer's meridian. Now LHA Aries is 5336. So from the observer's meridian, if I draw an angle of 53 degree 36 minute, this is where the meridian of Aries would be. So from the observer's meridian, we go in the westerly direction. You see, this is the westerly direction by 53 degree 36 minutes, and it gives us the celestial meridian of Aries. This is the location where Aries is going to be. Clear up to here, beta?
Yes, sir.
Very good. Now you see, we can find out the westerly R angle between Aries and star X. Now when Aries was at this particular location at the time of evening twilight, the Aries was at this particular location, and our star was at the location of X dash. So Aries is at this particular location, the celestial meridian of Aries represented by P Aries, and the star is on this particular celestial meridian, the celestial meridian of the star represented by Px dash n. Now we can easily measure this particular angle, the green color angle in the diagram. What is this green color angle? It is the angle at the pole contained between the celestial meridian of Aries and the celestial meridian of the star. And this is the definition of SHA. So the SHA of this particular star can now easily be found. You can see from this point, you can follow the laser pointer, from this point up to this point is 180 degrees. This is the angle between the observer's meridian and his inferior meridian. So this total angle is 180 degrees. The maroon color angle is 53 degree 36 minutes. So the green angle has to be 180 minus 5336. That gives us the value of 126 degrees 24 minutes. So we get the SHA of this particular star. The SHA of the star is known. Any doubts here, beta?
Yes, sir. Sir, if am I audible, sir?
Yeah, please go ahead.
सर अगर अभी जैसे ऑब्जर्वर इज बिलो द पोल
below the मतलब south southern, it's in the, अगर ऑब्जर्वर पोल के ऊपर होता, जो भी उसके इंफीरियर मेरिडियन, अगर ऑब्जर्वर वहां पे खड़ा होता एंड वुड हैव बीन बिकम द प्राइम मेरिडियन, तो एलएसटी जो हमने एंगल लिया, एलएचएस एरीज का एंगल लिया है, हमें दूसरा ऊपर वाले आई मीन जो उसके मेरिडियन ऊपर वाले मेरिडियन से लेना पड़ता ना वेस्टर्ली.
Okay, beta. What I will do is, after I complete this solution, na, I will draw this, whatever you are saying, and we will make a new horizon diagram. Okay?
Okay,
We'll do that
okay.
after the solution.
Okay, sir.
Okay. Okay, great. Now what we do is, you see we have this nx dash arc known to us. It is 13 degrees 08 minutes. We have the sx arc also known to us. It is 40 degree 20 minutes. And we are aware that from point S to Z is 90 degrees. Z to N is again 90 degrees. So this total N to S is 180 degrees. Now if I subtract 1308 nx dash and sx 4020 from 180, I can get the diameter of this particular circle. So 180 minus 13 degree 08 minutes minus 40 degree 20 minutes gives me the diameter of this circle, which is xx dash. Now if I divide the diameter by 2, I get the radius of this particular circle. The radius of this circle is px dash. Now this radius of the circle which I am getting is basically the polar distance of the star. This is the pole and point x or point x dash is the star. So px or px dash, both representing the radius of the circle, give me the polar distance of the star. Now we know 90 minus polar distance gives us the declination of the star. So once we calculate px, you see this is the value of px here. We know pole to equinoctial is 90 degrees. So 90 minus px gives you the declination of the star, which in this case comes to be 26 degrees 44 minutes. So we get the declination of the star 2644. We get the SHA of the star, which is 126 degrees 24 minutes. With these two values, we can now go into the star information table on page 268 and we can look for this particular SHA. And from there, we find out that this particular star is Alpha, having this given SHA and declination. Any doubts in this, beta?
To get x dash distance, we should subtract 180 minus 40 degree 20 minutes and 13 degree 08 minutes, correct, sir?
That's right, beta. That'll give you the diameter. Divide that by 2. Yeah.
I'm getting
How much?
126 degree 32 minutes, sir.
Very good, beta. Divide that by 2 to get the radius or polar distance.
Radius I'm getting 63 degree 16 minutes.
Very good. Now 90 minus that radius will give you the declination.
Yes, sir. 26 degree 44 minutes.
That's
Okay.
right.
Okay, sir.
Excuse me, sir.
Go ahead, beta.
Sir, in this diagram, just explain me when you draw the equinoctial, that will be below this declination circle 40 degree 20 minutes. So can you explain this one? This is measuring from pole to 90, that is Q. P to Q is 90, correct, sir?
That's correct, beta. P to Q has to be 90 degrees. So you get the Q point. Once you get the Q point, join W, Q and E to get the equinoctial.
Okay, sir. So P to Z is the difference, whatever. So we will South Pole be down below from QS. That will be same, sir. P to Z
Will be same, beta. बिल्कुल सही बोल रहे हो आप. You are right. The
Okay, sir.
arc P to Z will be same as Q to S. Both will be same.
Okay, sir. Okay. Thank you, sir.
Okay. Great, beta. Now let me take you to the whiteboard, beta. You had some doubt, so let's make that hypothetical question in the whiteboard. Give me a minute. Okay, beta. All right. So we have the question also, and we have the rational horizon diagram also. Let's try to make a diagram as you were saying. Now, beta, be careful. When we are making a hypothetical question, the question may not be correct, may not be right. So whatever you are saying, I'll try to put it here and let's see if it works out. So
Okay, sir.
you are saying that what happens if the pole comes south of point Z, right?
Right, sir.
Okay, let's see that. So that will happen if the northerly altitude is greater. That means one position of the star is somewhere here, and the southerly altitude is less, like this. If it happens this way, then you see the entire circle is shifted down like this. I missed the star, no problem. And the pole would come somewhere here, right, beta? This is what you wanted?
Yes, sir.
Okay. Now, if the pole is here, let's make the equinoctial. Now, Q point is 90 degrees away from the pole. If I go towards south, I will go outside the horizon diagram. If I go towards north, I will find the Q point somewhere here. So this is where you will have the Q point. And we can draw the equinoctial also. WQE will be like this. Okay, what else do you want to show in the diagram here, beta?
Now I want to know, sir, if we have to draw this LHA Aries, from which
Okay,
meridian we have to draw this, sir?
okay, beta, I will tell you now. Now we know that LHA of Aries is 53 degrees, right? LHA is measured from the observer's meridian, right? And observer meridian is the one which always passes from zenith. So in this case, the observer meridian is pole to zenith to Q to N. What I have shown in green is the observer meridian. So you have to start your measurement from here now. Okay.
Okay, sir. Understood, sir.
And you have to go in the westerly direction. So from this meridian going in the westerly direction, 53 degrees. This is how Aries would come in the picture now. And Aries is situated at the equinoctial, zero declination. So this is where you will have Aries, beta.
Understood, sir.
Clear, beta? Clear ho gaya?
Clear, okay, sir. Thank you.
Okay, all right. Very good. Important thing to note is, beta, if you have a north pole in your diagram, north pole, the westerly direction will be clockwise. And if you have a south pole in the diagram, like in this case, this is the south pole. Whenever the pole is southwards of Z, it is always the south pole. Whenever you have a south pole, the westerly direction would be anti-clockwise. Okay. So that is the important thing to be careful about.
Excuse me, sir.
Bolo beta.
Sir, I ask one question before that, sir. If it is right time to ask this one, or it will be depend upon you, sir. I have
No,
doubt
ask again.
about when this azimuth is given and LHA is given to identify the body. So
Okay.
from where is measuring from when we are having azimuth, from which place we are measuring. So can you show the two, three example for that to
Okay,
calculating
beta.
and it will
Okay.
differentiate. Is it right time, sir? Just I'm asking, sir.
Yes. Very right time. I will show
Okay,
you
sir.
here only in this diagram what is to be done. Okay.
Okay, sir.
Okay. I'm erasing this, what I have made. Okay. Let's close the slide. what I will do is I'll maximize it. Okay. Beta, give me, whenever these questions are asked, na, the DR position is given to you.
Okay, sir.
So DR position is given. Give me any latitude of your choice. Any latitude.
Any latitude, 20 degree north, sir. Like
Very good. 20 north. Give me any longitude of your choice. Any?
40 degree west.
40 west. Very good. So this was the DR position which is given to us. And in these questions, two things are given. One thing which is given is the azimuth of the star. Another thing which is given is the true altitude of the star.
Yes, sir.
Okay. These are given and then you are required to identify the star.
Yes,
Is it
sir.
the question you are asking?
Yes, sir.
Very good. Give me azimuth of your choice. Any azimuth, beta.
Anything like 070.
Very good. 070 is the azimuth.
Yes, sir.
Now give me any altitude of your choice.
15 degrees, sir.
15 degrees is the altitude. Very good. ग्रेट बेटा, तूने तो क्वेश्चन पेपर सेट कर दिया, क्वेश्चन बना दिया पूरा.
सर इसमें अगर LHA भी अपन इंक्लूड कर लें सर.
किसका LHA बेटा? बॉडी का LHA?
LHA of any body like sun, anything.
नो, वो इंक्लूड करोगे तो सवाल बहुत इजी हो जाएगा बेटा.
अच्छा,
LHA is not
okay,
given
sir.
in these
Okay, sir.
questions.
Okay, sir. Just try to.
Okay, all right. Anybody wanting to ask something? Okay, so let's see this first. Now my latitude is 20 degrees north. It tells me zenith has to be 20 degree north of the equinoctial. Or in other words, equinoctial should be 20 degrees south of zenith. So Q will come here.
Yes, sir.
Let's make the equinoctial. Equinoctial is WQE. Let's make the pole also. The pole is 90 degrees away from Q. The pole would be here. Let's draw the azimuth of the body. Azimuth is 070. 070 azimuth is going to be somewhere here. This is the azimuth, 070. Agree, beta?
Yes, sir.
Very good. Let's show the altitude also. Altitude is 15 degrees. So from the horizon, I go 15 degrees and this is where the body is. Let's show the body with a green color. The body is here. Right, beta? Agree?
Yes, sir.
So this azimuth, how it is measured? So from where it is measured? Sir?
Okay, beta. If it is in the three-figure notation, it is always measured from north and it is measured clockwise.
Okay, sir. Okay, sir.
Okay. Great. So we have the body. Let's call the body as X. And let's now draw the celestial meridian of the body, which is PX. ये बेटा मैंने PX भी draw कर दिया. Okay. Now altitude is 15 degrees. Altitude is 15 degrees. Basically this arc is 15 degrees. Can you tell me what will be ZX?
ZX 90 minus 15, 75, sir.
Very good. So this is 75. Latitude is 20. So this tells me Z to Q is 20 degrees. Can you tell me what is PZ?
PZ is 90 minus 20, sir.
Very
So
good.
70.
70 degrees. Great. Now beta, look at the PZX triangle. PZX.
Yes, sir.
I know side PZ. I know side ZX. I know angle Z. Which
Yes, sir.
formula can we apply?
Cosine rule, sir. By cosine rule.
Very good. Two sides and the included angle is known. Cosine formula is applied. When you apply the cosine formula, you will get Px first.
Yes, sir.
Px is the polar distance. 90 minus Px will give you the declination. So
Yes,
declination can be obtained.
Yes, sir.
Okay. The second thing you find using cosine formula is this angle P.
Angle P.
Okay. This angle P is the EHA, easterly R angle. 360 minus this will give you the LHA. This is the LHA, beta.
Okay, body easterly.
LHA is measured westerly, EHA is measured easterly. This is east, this is west. Okay, so you get the LHA of the star. Right, beta? LHA
Yes,
star
sir.
aa gaya? Okay. Now you can get GHA of the star also, because you have your longitude 40° west. You can get the
Yes,
GHA star.
yes, sir.
Okay. GHA Aries is available in the almanac,
Hmm.
right? Difference
Yes, sir.
between these two difference will give you the SHA of the star. Right?
Yes, sir.
Once you know the SHA and you know the declination, you go to the table and see which star is that. Question solved.
Yes, sir.
25 marks.
Sir, but here for GHR is we should know the GMT, right?
They will give you beta. In this question, they'll give you the time.
Okay, sir.
Sir, just one more thing. From Z to X, how this is 75. How
Okay,
this
beta.
one came, sir?
Okay, beta. Okay. Beta, this line which I am highlighting in red is the true altitude. This one. From the horizon to the center of the body, this is true altitude. Z to horizon
Okay,
is
okay, okay,
90. So this
okay.
is 90 minus true
Yeah,
altitude, which
yeah.
is 75.
Okay, understood, understood.
Sir,
Okay. बोल बेटा.
यहाँ पे सर टू थिंग्स डिफरेंट था जो आपने अजीमत का मेजरमेंट किया है दैट इज फ्रॉम ईस्ट डायरेक्शन मींस नॉर्थ
No,
नॉर्थ
it's
से
from north,
लिया है
beta. Azimuth, three-figure notation azimuth always measured from north
नॉर्थ
clockwise.
एंड देन एलएचए का जो मेजरमेंट है वो अपने अदर डायरेक्शन मींस EHA will be same but after all 360 minus EHA किया है सो LHA का मेजरमेंट का के लिए कौन सा सर रेफरेंस लाइन रहेगा
LHA is measured always west. LHA is measured at the pole. Azimuth is measured at the zenith.
Azimuth is measured from zenith, but direction will be from north.
Clockwise. Clockwise.
And sir, agar questions almost same, but the if pole will be changed. Suppose if we are in South Pole and this will be the questions, and then can you draw this diagram, sir, for South Pole?
Okay, all right. Okay. Let's make it for the south. I'm erasing it now.
No, no, sir. Means body will be here, but we are seeing from South Pole. So
Okay. ठीक है बेटा, 20 नॉर्थ को हटा देते हैं. इसमें से जो चीजें चेंज होंगी उनको भी मैं हटा रहा हूँ. पोल भी चला जाएगा, ये भी चला जाएगा, बॉडी यहीं पे रहेगी.
बॉडी यहीं पे बट साउथ पोल में.
वेरी गुड. अभी बना देते हैं साउथ पोल. लो बेटा, इसे 20 डिग्री साउथ कर देते हैं. ओके.
यस सर.
20 साउथ का मतलब है द ऑब्जर्वर इज 20 डिग्री साउथ ऑफ द इक्विनॉक्शियल.
यस
इसका मतलब है इक्विनॉक्शियल इज 20 डिग्री नॉर्थ ऑफ द ऑब्जर्वर. So from Z 20 degrees north, this is where Q point is. And if we join W to Q to E, this is equinoctial. 90 degrees away from the equinoctial, the pole will be this side. This is where the
Yes,
pole
sir.
is. Okay, let's draw PX. This is PX now, beta.
Yes, sir.
And this is the PZX triangle now. You will solve it like this.
So azimuth
This.
is still with 70, sir.
Azimuth has to be with north, beta. 070 azimuth has to be with north.
Okay, okay, sir.
Azimuth is always with reference to north.
And
This
then
will be
LHA will
EHA.
be
I'll show you. This is the
Sir,
EHA.
can you azimuth at south 45 degrees.
1 minute. This will be the LHA. This is how it will be now.
LHA, sir, this arrow I think will be other side, right, sir? But angle will be this one.
No, beta, the arrow is also correct. From the observer meridian in the westerly direction. From the observer meridian in the westerly direction. This is how LHA is measured.
Southern hemisphere
Anti-
always.
Southern
okay.
hemisphere, anti-clockwise.
सर एलएचए का सर कैसे सर ये हो जाएगा सर? ये तो डायरेक्शन इसकी बदल गई, ईस्टर्ली हो गई डायरेक्शन सर, ऐसा लग रहा है
नहीं बेटा,
देखने में।
बिल्कुल नहीं हुई ईस्टर्ली। अभी दिखा देते हैं तुम्हें। हमारा मेरिडियन है PZQN। ये ग्रीन कलर का हमारा मेरिडियन है बेटा, ठीक है।
ओके सर।
अब मान लो मैंने यहाँ मेरिडियन पे ना एक डंडा लगा दिया, ये ग्रीन कलर का एक रॉड लगा दिया यहाँ पे। अब इस रॉड को तुमने पकड़ना है, इसको पकड़ लो, कहीं से भी जोर से पकड़ लो और इसे वेस्ट में लेके जाना है बेटा। कैसे घूमेगी ये रॉड? ऐसे ही घूमेगी ना बेटा।
करेक्ट सर, करेक्ट सर।
सो दिस इज द वेस्टर्ली डायरेक्शन बेटा।
करेक्ट सर, दैट इज आवर बेसिक डाउट सर, इसीलिए यहाँ से मेरा गड़बड़ हो जाता था सर, दैट कैलकुलेशन पार्ट। वो सेम ही डायरेक्शन पे मैं ले रहा था साउथ पोल में भी, इसलिए मुझे बार बार इसमें कंफ्यूजन हो जा रहा था सर। एनीवे, थैंक यू सर।
मैं ऐसा और एक सवाल आपको करवा देता हूँ, साउथ पोल
Sir,
वाले
now
एक दो सवाल और
angle
करते हैं।
Z will be 180 minus 70, right, sir?
Yes beta, that's right. You see angle Z is this angle now.
So the included angle is 110.
Yes.
110।
Okay. Now one
Okay,
thing to keep in mind, if the azimuth is not three figure notation, this was three figure notation azimuth 070. If the azimuth is given in quadrantal notation, then you have to go in the quadrant.
Yes,
Like
sir.
somebody said, South 45 East का azimuth बनाइए. If the azimuth is South 45 East, beta, now the reference will not be north. For quadrantal azimuth, the reference will be the one which is given, south. So from south direction, you go towards the easterly direction by an angle of 45 degrees. This is where the body is going to be. This is quadrantal azimuth. This is where the body is going to be. Okay?
Okay, sir.
Great. अब मैं ऐसे
Thank you,
सवाल
sir.
और आपको दिखाता हूँ. I'll show you more questions. With that, it will become all the more clear. Some tricky questions I'll show you.
Yes, sir. Thank you.
Let's now move on to the next question. On 13th of October 1992, in latitude 62 degrees 30 minutes north, star Vega bore 270, and at the same time, an unknown star bore north with an altitude of 34 degrees. Identify the unknown star. We will follow exactly the same approach in this question. That is, we will make the rational horizon diagram and we will feed or input all the information what is given to us in the question in that diagram, and the diagram will give us a lead. So let's put all the information in the rational horizon diagram. We have the rational horizon on the screen now. We can show the NESW points. The center of this diagram represents the zenith of the observer. So you see the Z, the zenith coming up in the center. Irrespective of where the observer is or where the body is, these 5 points NESW on the rational horizon and point Z at the center remain at these locations only. Now in this question they have given us the latitude. The latitude is 62 degrees 30 minutes north. So it tells us that the zenith will be the north of the equinoctial or the Q point. Or in other words, the Q point would be south of the zenith. And we know that the arc ZQ, Z to Q, represents the latitude of the observer, and this in our case is 62 degree 30 minutes. So from the zenith I go 62 degrees 30 minutes south, and this is where the equinoctial would pass, and I will have the Q point. So you see the equinoctial is passing from Q point, and the equinoctial always passes from the east and west points. So this WQE, which we have on our diagram now, represents the equinoctial for this particular observer. Now once the equinoctial is there, we can also show the pole. The pole, in this case the observer is in north hemisphere, so we will have the north celestial pole as our elevated pole or visible pole, and the pole is 90 degree away from the equinoctial or the Q points. So from the Q point I go 90 degrees away, and this is the point where I have the pole. Let's represent this point as P. We have the pole in the diagram now. Now the next information which the question tells me is that star Vega bore 270. Now in this diagram, the 270 bearing is represented by line ZW. ZW represents 270 bearing. So Vega has to be somewhere on this line. I don't know the altitude of Vega, so I will pick up any random location here and I will put star Vega in this location. So we have the star Vega in our rational horizon diagram now. Now the next information which is given in the question is the unknown star bore north with an altitude of 34 degrees. At the same time, when Vega was sighted, the unknown star was bearing north with the altitude of 34 degrees. Now coming back to our diagram, the ZN line represents the north bearing or 000 bearing. So the unknown star has to be somewhere on this line. Its altitude is given to us as 34 degrees. Now point N is on the horizon. Our star is 34 degrees above the horizon. So from point N going 34 degrees above the horizon, this is where the unknown star is. Let's mark the unknown star as X. So you can see now that all the information what was given to us in the question has been fed in the rational horizon diagram. Any doubts,
Sir,
beta?
sir,
Go ahead,
excuse me,
beta.
sir.
Go ahead.
Sir, as per diagram, this is a understand thing, sir, no issue. But one question comes in my mind, maybe you will laugh on this. Sir, as per body, second one, whatever you are taking 34 degree from north, it's look like from the north of the observer. But from between there is point P, pole. So it will be still as known as a north of observer, or it's going below the pole.
Okay, beta, the body is certainly below the pole. You are right. But the bearing of the body will always be north.
North, yes, sir. Okay, sir. So it will be always north. Either it is below the pole or above the pole. That doesn't make any difference.
Yes, that's right.
Okay, sir. Okay, thank you, sir.
Okay.
Sir, can you repeat the one more time, sir?
What, beta? What do you want?
Please, can you repeat one more time, sir?
Which part you are having doubt, beta? Tell me.
Also, from the zenith Q and sir, the Vega is on the east and west direction, sir.
So your doubt is why Z2Q is 6230?
This is already given, sir. This is latitude, sir. This is latitude
Yes,
given.
that's right, beta.
And then this is also will given the altitude of the bodies, sir. Unknown bodies.
Correct.
The,
That's right.
yes.
34 degrees is given.
Sir, Vega is, sir. Why the Vega is, sir?
Okay, beta.
Vertical.
The bearing of Vega is given, beta, 270. So we have to mark Vega on ZW line. Altitude is not given, so you can mark it anywhere.
Okay.
Okay,
Yes, sir.
you can mark it
Yes, sir.
anywhere.
Okay, thanks, sir.
Okay. Now, what we do next is, I have star Vega in my diagram, and I have the pole, I have the zenith. So I'm going to draw the celestial meridian of star Vega. Its celestial meridian will originate from the pole and it will pass from star Vega extending downwards. So let us show the celestial meridian in the diagram. The maroon color line which you see from P going up to Vega and going further is the celestial meridian of Vega. Now concentrate your attention to the arc P to Vega. P to Vega. Now this arc is basically the polar distance of Vega. Polar distance of Vega. And we know that the polar distance is equal to 90 minus declination. You see, from Vega to the equinoctial, this is the declination, which I'm showing with the help of the laser pointer now. This is the declination of Vega. And we know equinoctial to pole is 90 degrees. So P to Vega has to be 90 minus declination of Vega, and it is called as polar distance. Now we have the date 13th October 92, and we can get the declination of the Vega from the nautical almanac. So once you do 90 minus that, you get the polar distance. This is the value of the polar distance which will be obtained. So we have the Papa Vega side, P Vega side known to us. Now have a look at the PZ Vega triangle. Okay, I have named it as Vega, otherwise this is the PZX triangle. So in this triangle, I'm showing that triangle with the help of the laser pointer now. Now in that triangle, you see angle Z is a right angle. Because star Vega is at 270 bearing, the pole is north of the observer. So the angle Z is 90 degrees in this particular diagram. And in this triangle, we know the side PZ, Papa Zulu side, is known to us. It is the co-lat of the observer, or 90 minus latitude of the observer. The latitude is 6230. So 90 minus that is the side Papa Zulu PZ. That's why it is shown with a green tick. Now we also have the Papa Vega side, which is the polar distance of Vega, 51 degrees 13.1, which we calculated, found earlier. Now you see in this triangle Papa Zulu Vega, PZ Vega, it's a spherical triangle. All the three sides are great circles, and it has a speciality. Angle Z is a right angle. So we can apply the Napier's rule in this triangle, and we can find out anything else using these two known values. So I will apply the Napier's rule in this triangle, and what I'm going to find out is this angle P. Let me show that with the arrow in the diagram. This angle P is what I'm going to find out. So using Napier's rule, using the two known, I'm going to find out this angle Now this angle P is basically the LHA of star Vega. It is the LHA of star Vega. Now the LHA of star X, if you look carefully, the star X is on my inferior meridian. It is on the other side of the pole. P to N is the inferior meridian of the observer. So anybody on the inferior meridian, its LHA is 180 degrees. So LHA of the unknown star is 180 and the LHA of Vega has been found. This is known to us now. So I can, from this information, find out this angle, which I am highlighting with the laser pointer. And what is this angle? This angle is November Papa Vega. This is the angle which I am talking about. November Papa Vega. And what is this angle here? This angle is LHA of the unknown star minus LHA of Vega. Or you can say it is the difference of R angle between Vega and the unknown star. Angle at the pole contained between celestial meridian of Vega and celestial meridian of the unknown star. So it is the difference of R angle between Vega and this particular star. Now once I know this angle, I know this is the difference between SHA of the star X and the SHA of star Vega also, because this is the R angle, difference of R angle between the unknown star and Vega. So SHA is also a R angle. So whatever is the SHA of Vega plus this angle is going to give me the SHA of the unknown star. Beta, please mute your mics. So what I am going to do now is I will check the SHA of Vega on 13th October 1992 from the almanac. To the SHA of Vega, I will add up this particular angle and I am going to get the SHA of the unknown star. So we will find out the SHA of the unknown star. Now, to identify a star, along with SHA, we also need its declination. So let's now see how do we find out the declination of the unknown star.
Sir, I have a doubt in this SHA. Now, what you said is this angle P till Vega is the LHA.
That's right.
And then 180 minus this angle P will give me this angle P.
November Papa Vega.
Yes, sir.
Right. What's the doubt, beta?
So, sir, this SHA X minus SHA Vega, why it's like that, sir?
Okay, beta. Okay. Beta, this angle November Papa Vega is basically the R angle between Vega and the star. Do you agree?
Yes, sir.
Okay. Let's say this angle is 60 degrees. Okay. Now, whatever is the SHA of star Vega, the SHA of star X will be 60 degrees more than that, because this is the difference between Vega and the star, na?
Okay.
Okay. Let me find out the declination. मैं इसके बाद आपको ना डायग्राम में एरीज बना के दिखाता हूँ, फिर क्लियर हो जाएगा.
वही थोड़ा वो कंफ्यूजन हो गया था सर. Exactly.
No problem. I will show the areas. Let me do the declination calculation, then I'll show.
Okay, sir.
Concentrate your attention on November to Papa. November to Papa is the elevation of the pole or altitude of the pole. Now we know that the elevation of the pole or altitude of the pole is equal to the latitude of the observer. and we know the latitude is 62 degree 30 minutes. So November to Papa is equal to 62 degrees 30 minutes. November to X-ray, which is the true altitude of the star, is 34 degrees 00 minutes. So I can now easily find out the difference between them. It is going to give me Papa X-ray, Px. So in this case, the Px is going to be 28 degrees and 30 minutes. It is Np minus Nx. Np equal to the latitude is 6230. Nx, the altitude of the star given in the question, is 34 degrees, giving us Papa X-ray Px as 28 degrees 30 minutes. Now, if you look carefully, Papa X-ray Px is the polar distance of this particular star. Now, we know polar distance is 90 minus declination. So once we have the polar distance, 90 minus the polar distance is going to give us the declination of the star. So we can obtain the declination of the star. Since it is the polar distance from the North Pole, the declination will have a northerly name. It is close to the North Pole, so the declination of the star is north. So once we find the SHA and declination, SHA comes out to be 195.33 and declination comes out to be 61 degree 30 minutes. We can go to the star information table on page 268, look for this SHA 195.33, match the declination, and we can identify the star as Dubhe. So this is how we solve this question. So used the same principle, put all the information in the rational horizon diagram, applied the spherical trigonometry, Napier's rule, and we were able to find out the SHA and declination of the star, identifying it. Okay, let me now show you how do we find the SHA. Give me a minute.
Sir, before going further, sir, here you choose the direction.
1 minute, beta. I'm opening it up. Go ahead now.
Sir, declination direction जो north and south confirmation sir लिया उसके बारे में sir last आपने जो statement बोला था because this will be north 61 value is okay 90 minus polar distance but then directions का sir.
Okay, beta. So your doubt is whether the declination is north or south, right?
Yes sir.
Okay. Tell me, beta, this pole in the diagram, is it the north pole or the south pole?
It's north pole sir.
If you are 28 degrees away from the north pole, are you in the north hemisphere or south hemisphere?
North hemisphere sir.
So this body is in the north hemisphere. That's why declination north.
Okay sir.
Clear?
Yes sir.
Okay. Now I will clarify you about the SHA also. Beta, can you tell me on 13th October 92, just look at the almanac, tell me what is the SHA of Vega?
Sir, it's 80 degree 41.5 minutes. SHA.
Very good. 80 degrees. I've shown the SHA of Vega in the diagram, beta. Can you see that red color angle? Is it clear, beta? The red color angle, SHA of Vega? Can you see the yellow color angle also now?
Yes, sir.
Okay. Now tell me, if I add this red angle and the yellow angle, I'm going to get the blue color angle. Agree, beta? Red angle plus yellow angle give me the blue angle.
Yes, sir.
Okay. So I'm writing it here. Red angle is SHA of Vega. The yellow angle is what we had calculated. Okay. The yellow angle is basically NP Vega. I will write NPV is equal to the blue color angle. And look carefully at the blue color angle. It is the SHA of the unknown star. Angle at the pole contained between Aries and the particular star measured westwards. This is the SHA of the unknown star. This is how we get the SHA. Is it clear now, beta? Doubt is resolved.
Just
Whose
a
doubt
moment,
was
sir.
that?
Just a moment, sir.
Okay. Have a look.
ये एरीज सर, एरीज वहाँ उस साइड क्यों आया सर 80 डिग्री के लिए?
Okay, beta. Vega is 80 degrees west of Aries. ये आपने बताया मुझे एल्मेनाक में लिखा 80 degree is the SHA of Vega.
Yes, sir.
So Aries has to be 80 degree east of Vega. As simple as that. इसीलिए मैं वेगा से 80 डिग्री ईस्ट गया और मैंने एरीज बना दिया.
Okay, sir.
क्लियर हुआ बेटा जिसका डाउट था? Whose doubt was that?
Yes, sir, it was mine.
Okay, all right. Clear now, beta?
Yes, sir.
Okay, great. Very good. So can we close this now? Clear?
Yes, sir.
Great. Very good, beta. Okay. So shall we take a 5 minutes break, beta? इसके बाद और क्वेश्चन पिक करते हैं.
Okay, sir.
Okay, let's be back after 5 minutes. ये बेटा बैक चले आगे.
Yes, sir.
Very good. Let's go. Let's move on to the next question now. Let's move on to the next question now. For a stationary observer, the true altitude of an unknown star when bearing south was 14 degrees 11.2 minutes. 1 hour and 7 minutes later, the true altitude of star Betelgeuse, having a SHA 271 degrees 17 minutes, declination 7 degrees 24.5 minutes, when bearing north was 47 degrees 25.5 minutes. Identify the unknown star. So let's try to put all this information in the rational horizon diagram. At a certain point, the unknown star was bearing south. The altitude was 14 degree 11.2. So after that, the observer waited for 1 hour and 7 minutes. And after this much time, he observed that star Betelgeuse was bearing north with a altitude of 4725.5. So we need to identify the unknown star. Let's make the rational horizon diagram. We have the rational horizon, points N, E, S, W marked. Let's mark the center as the zenith of the observer. We have the zenith on the diagram now. The information given in the question is unknown star was bearing south. That means line Z to S, south bearing, and altitude 14 degrees 11.2. So from the horizon, which is point S, we are 14 degrees 11.2 minutes away. So let's mark 14 degrees 11.2, and this is where the unknown star is. We have the unknown star in our rational horizon diagram. Now 1 hour 7 minutes later, the star Betelgeuse was bearing north. North bearing is Z to N, and the altitude of star Betelgeuse was 4725.5. So N point on the horizon, 47 degrees 25.5 minutes away from it. 4725.5 is where we have Betelgeuse. So we have the Betelgeuse also in our rational horizon diagram. Now, on this particular day, the declination of Betelgeuse was 7 degrees 24.5 minutes north. In other words, Betelgeuse is 724.5 north of the equinoctial. Now this tells me equinoctial is 7 degrees 24.5 minutes south of Betelgeuse. So from star Betelgeuse, I go 7 degrees 24.5 minutes south, and this is where the equinoctial should be passing. So I get my Q point, and I know the equinoctial will pass from Q. Equinoctial always passes from the west and east points. So I can now mark off the equinoctial in the diagram as WQE. WQE is the equinoctial. Now I can easily find out the arc Z to Q. I know what is N to Betelgeuse. It is 4725.5. I know Betelgeuse to point Q is 724.5. And I know N to Z is 90 degrees. 90 degrees is the radius of this diagram. So 90 minus 4725.5 minus 724.5 gives me ZQ, which is 35 degrees and 10 minutes. So this 3510 is the latitude of the observer. ZQ is the latitude of the observer. So observer's latitude is 35 degrees 10 minutes south, because you see the zenith is south of the equinoctial. So 35 degrees 10 minutes south is the latitude of the observer. Now once I know the latitude, I can mark off the pole also. The pole is 90 degrees away from the equinoctial, and it has to be somewhere here. So this is where the pole is, and I know that the elevation of the pole or altitude of the pole, in this case S to P, is the elevation of the pole. It has to be equal to the latitude of the observer, which is 35 degree 10 minutes. So S to P is 35 degree 10 minutes. S to the particular star is 1411.2. Now this helps me to get the polar distance of the star P to this particular star. It is 3510 minus 1411.2 and 20 degrees 58.8. So I get the polar distance of the unknown star, and 90 minus polar distance gives me the declination of this particular star. The declination will be south, because we can see the star is 20 degrees away from the south pole. So 90 minus this gives me the declination. I get the declination of the star as 69 degrees 1.2 minutes south. Any doubts, beta?
No, sir.
Very good. Go ahead, beta. Any doubts? You have raised your hand.
No, sir.
Okay, all right. Now let's draw the declination circle of the unknown star. The star is here. The declination circle will pass from the position of the star and it will be centered at the pole. So we have the declination circle of the star in our rational horizon diagram. The star will be moving in the direction of the arrow. Like this, the star will be moving in this particular direction. Now, whenever you want to check the direction in which the body will be moving, consider that we have a celestial body on the equinoctial. Now that celestial body will be rising at point E, moving along the equinoctial, and it will be setting at point W. All the bodies rise on the eastern horizon and they set on the western horizon. So whatever direction this body is moving on the equinoctial, the same direction will the declination circle have. The star is also going to move in this particular direction only. So that gives us the direction in which the star is moving. Now the question told us that when we observed the star, the next observation was taken 1 hour and 7 minutes later. Betelgeuse was observed 1 hour 7 minutes later after the observation of this unknown star. So let us now try to see, after 1 hour and 7 minutes, where will the unknown star be? Unknown star will be moving in this particular direction on its declination circle. Now we know that stars cover their hour angle at a rate of 15 degrees 2.5 minutes. So in 1 hour and 7 minutes, the star is going to cover an hour angle of 16 degrees 47.8 minutes. So let me show this hour angle in the diagram now. From this position, the star is going to move in this direction by an amount of 16 degrees 47.8 minutes. So this is where the star is going to be. Now let me draw the celestial meridian of the star. We name the star as X, and P2X represents the celestial meridian of this particular star. Now once I have the celestial meridian on the diagram, I can now also easily find out angle ZPX. Pay your attention to this particular angle, ZPX. We can easily find out this angle as 180 minus the hour angle of the star. So 180 minus 1647.8. 180 minus 1647.8 gives me the angle ZPX as 163.12.2 minutes. So let's mark it in our diagram. This is the angle which we have found now, and this angle is 163 degrees 12.2 minutes. Now if you look carefully in the diagram, this is the pole and this is star Betelgeuse. This is the celestial meridian of star Betelgeuse. PZQN is the celestial meridian of star Betelgeuse. And the celestial meridian of the unknown star is PX. Now if you look carefully, this unknown star is 163 degrees 12.2 minutes east of Betelgeuse. This is where Betelgeuse is. If you go in the easterly direction, see this is the easterly direction. So from Betelgeuse, if you go in the easterly direction by an angle of 163 degrees 12.2 minutes, you reach up to the unknown star. Or in other words, the unknown star is 163 degrees 12.2 minutes east of Betelgeuse. So this tells me that the SHA of the unknown star will be SHA of Betelgeuse minus 163.12.2. Why there is a minus here? Because SHA is a westerly measurement. SHA is measured in the westerly direction. If the star was west of Betelgeuse, we would have added this angle. But the star is east of Betelgeuse, so we have subtracted this angle from the SHA of Betelgeuse. It will give us the SHA of the unknown star, which comes out to be 108 degrees 4.8 minutes. So SHA of Betelgeuse is available to us from the almanac. Minus this value gives me 108 4.8, which will be the SHA of the unknown star. So now I have the SHA of the unknown star as well as the declination of the unknown star. Using these two values, if I go to the star table on page 268, I can easily look out for the star and it comes out to be Atria. So the unknown star is Atria. So you see we followed exactly the same approach. We put all the information in the rational horizon diagram and we got the answer. We got the unknown star.
Sir, can you show the previous page? Take a screenshot.
Okay, beta. Okay, I'll show you. Here it is, beta.
Yes, sir. Thank you.
Okay, great. Okay, so shall I close this, beta?
Sir, declination of unknown star, sir, that part not clear, sir. Declination part of
Okay, beta.
unknown star.
You have the diagram in front of you. Tell me where is the doubt coming?
Declination, सर सर्किल जो लिया ना सर अपन नॉन स्टार का वो सर थोड़ा सा मैं नहीं क्लियर हुआ है, बताएंगे सर कैसे कंफर्म किया था डेक्लिनेशन उसका सर?
ओके, स्टार की डेक्लिनेशन जो है वो 69 डिग्रीज कैसे आई, ये डाउट है ना?
नहीं, ये तो हो गया सर, 69 डिग्री हो गया सर। अपने सर्किल लिया था ना जो पोल पे, वो वाला डायग्राम सर। हाँ, इसमें सर।
सो ये सर्कल हमने बनाया स्टार का।
यस सर।
इस सर्कल में क्या डाउट आ रहा है बेटा कि ये एंटी क्लॉकवाइज क्यों घूम रहा है?
नहीं सर,
हाँ,
वो तो
क्या
आपने
डाउट आ रहा है?
कैलकुलेशन से 69 डिग्री लिया ना सर, 16 को माइनस करके 90 से, तो
राइट।
69 डिग्री डेक्लिनेशन जो बनेगा वो सर पोल से सर कैसा आया सर उसका डायग्राम सर, ये डेक्लिनेशन सर्कल का सर?
ओके ओके ओके, एक मिनट अभी बना देते बेटा, गिव मी अ मिनट।
यस सर।
सो हमारी बेटा डेक्लिनेशन जो है ये 69 डिग्री साउथ आ गई, राइट?
यस सर।
अब बेटा इक्विनॉक्शियल जो है इट इज रिप्रेजेंटेड बाय WQE.
ओके।
So from the Q point, I go 69 degrees south. Okay. And I reach here.
And
this is 69 degrees south.
Okay, sir.
Right, beta? So I come
Yes,
to
sir.
this point And this is where the star is. The unknown star is here, and it will be moving in this particular way. All the bodies go from east to west,
East to
like
west.
this.
Yes, sir.
So this is how the star will be moving, and that's how we made the declination circle.
And then after 1 hour, it will become on point another x1 16 degree 47 minute point.
Right.
Sidereal
beta.
hour.
Initial observation, it was here, and after 1 hour, it will cover this much of distance. So this green color angle is 1647.8.
Yes, sir.
It
Okay,
will
sir.
come at this location.
Yes. Thank you, sir.
Okay, beta. Good. Closing this down now, beta. Okay, all right.
सर दोनों में से if SHA star or declination,
Mhm.
if we find something, if one answer is wrong, फिर तो वो स्टार तो पता चलेगा नहीं.
नहीं बेटा, दोनों के दोनों ही हमें सही मिलने चाहिए, because we need both these items to identify the star.
अगर
So
सिर्फ
अगर ये
declination,
match,
अगर सिर्फ declination देख के स्टार पता चल जाए तो SHA बदल जाएगा.
ना, declination से तो बिल्कुल पता नहीं चलेगा, because there can be many star of similar declination.
Okay, sir.
Okay, so you have to find both of them. If आप देखते हो कि जो SHA declination आया है, there's now let us say there is a situation that whatever SHA declination you found, no star is there in the table. Okay,
Yes, sir.
so you mention it as such. First recheck your calculation, see if there is any error. If you have rechecked it and no error comes, you just write there the SHA of the star is this much, declination is this much, and there is no such star in the stars table. Mention it as such. If your calculation is right, you will get full marks.
Okay, sir.
Okay, but double check you are working, because normally all these questions are made so that you can identify some star. Star should be there in the table.
Right, sir.
Okay, अभी तक ऐसा सवाल आया नहीं है कि वो मिले ही ना टेबल में.
Yes, sir.
Okay, great. Now, beta, I told you the definition of local sidereal time. Now, there are some more definitions related to time. Okay, so also with these definitions, there is one more concept which is there, and that is the concept of equation of time, true sun and the mean sun. So, shall we do that, beta? Shall we go ahead and do that? Or are you saturated? High level alarm तो नहीं आ रहा?
सर कल कर लेते नेक्स्ट क्लास.
Okay, all right.
So if we got two, three questions, 1, 2 questions of this type only, we can do if it's there.
Not 1, 2, I'll send you 20 today.
Okay, sir.
Don't worry. Okay.
Okay, sir.
I will send you an assignment. In that assignment, leave the first 11 questions, beta. Don't attempt the first 11 questions. उनके concept मैं आपको कल करवाने वाला हूँ. Those are the concepts of chart projections and Kepler's laws of planetary motion that we will cover tomorrow. Okay. So leave first 11. After 11, the remaining questions are rational horizon based questions. The ones which we did in the class also, they are included there. So try attempting those questions. That will take care of the rational horizon questions. Okay, बेटा?
सर उनके सोल्यूशन भी आपके पास?
बताओ तुम्हें चाहिए?
सर मिल जाएंगे तो अच्छा है, टाइम कम लगेगा.
Okay, ठीक है बेटा, भेज देता हूँ. I'll send.
We can understand ourselves only, sir, what mistakes we've done or something, because sometimes in these the angles also sometimes we measure it wrongly and then we're just figuring out what is wrong and how the answer is not coming.
Okay, no issues. I'll send the solutions also.
Yes.
Look at the solution only to take a hint. Don't copy them.
No,
Sir, how many questions are there, sir?
About 20, beta. First 11 you leave, so you have about 11, 12 to practice.
So that means that all 20 questions
9,
have
10.
all kind of periodic triangle questions that can be there in the exam, sir.
That's
Thank
right.
you, sir. Thank you, sir. Thank you, sir.
Okay. So do that assignment, practice those questions. And tomorrow we are going to cover the concept of two topics we are going to cover. These are basically the only two topics remaining now in our paper. So these are one, Kepler's laws of planetary motion and numericals based on that. And second is the chart construction. Okay. So how to construct a Mercator chart. So these are the only two topics remaining, other than a small topic of time, which we will obviously cover. So I hope that tomorrow we should be able to close out the syllabus.
Okay, sir.
Okay.
Okay, sir. Okay, sir.
Right. If any spillover is there, then that can be covered up in the Monday's class. So hopefully tomorrow we will cover it up. So you have good time to practice and be ready.
Yes, sir.
Okay. All right, beta. So we'll call off for today. Practice these questions and we'll cover the remaining topics tomorrow. So see you then, beta. Bye bye.
Thank you, sir.
Thank you, sir.
Good night, sir.
Sir,
Arvind, you want asking something?
sir, I have doubts. Thank you, sir. Sir, yesterday you sent an assignment regarding that. The first question and the first question, the